In this video, we'll be looking at what are component of one vector on another. It is also called projection of one vector on other. So we'll see what do we actually mean by that. Let's say there are two vectors. One is this vector A and another is vector B, and we have some angle between them, let's say theta. Now we want component of vector A on B. So what we'll do, we'll draw a perpendicular on B and take the base, or we'll take the component of A which is parallel to B. This is called component of A parallel to B. And this you can easily see that what will be its magnitude and what will be its direction. So we name it as A parallel B. So A parallel B has a magnitude of B cos theta, A cos theta has a magnitude of A cos theta, and its direction is along vector B. So the magnitude is this A cos theta and the direction is along B vector. So we can add a B cap. You must have watched the previous videos and have explained the component of a vector and a unit vector. So A cos theta B cap is nothing but component of A parallel to B, which we named A parallel B. So how we calculate this? We already know from the dot product that A cos theta is nothing but A dot B divided by magnitude of B. So it will be A cos theta and B cap. So we can easily say A dot B divided by B, and B cap can also be written as B vector by B cap. B vector by magnitude of B. So this is nothing but projection of A on B, or component of A parallel to B. In a similar way, if we have to find component of B parallel to A, we can say it will be A dot B divided by, we want B cos theta, this will be B cos theta A cap, so it will be A dot B divided by magnitude of A into A cap. As the vector is parallel to A, it will be A cap, can also be written as A dot B by A into vector A by magnitude of A. So this is how we calculate the component of vector A along vector B. Let's take an example. Let's say this is a 5 unit magnitude vector, and this is vector A, and the angle is, let's say, 37 degree, and this is a 20 unit vector which is vector B. So what is A parallel B? Component of A parallel to B is nothing but 5 cos 37 B cap. So we can write it as 4 B cap. What about component of B parallel to A? Nothing but 20 cos 37 A cap. So it will be cos 37 again 4 by 5. So 20 into 4 by 5 into B cap, that is 16 B cap. So we can easily get the component of one vector along another. But what if the vectors are not in the diagram form, they are in vector form? So we have to take this help of the dot product. This is one of the application of the dot product. So let's take that example. Before going further, we can just see this is also termed as A parallel to B. The magnitude of this is nothing but A sin theta, because the magnitude of A parallel B is nothing but A cos theta. As this is the base, we can say this will be cos theta and this will be sin theta, A sin theta, A cos theta. Now we have to find the component of A along B. A and B are two given vectors. So component of A parallel to B or projection of A on B, both are same things. So it will be A vector dot B vector divided by the magnitude of B into B cap. So when we take the dot product, it will be 3 plus 8 divided by magnitude of B, which is nothing but 5. 3 square plus 4 square is 5. And B cap is nothing but 3i plus 4j divided by its own magnitude, which is 5. So we get component of A parallel to B as 11 by 5 into 3i plus 4j by 5. We should write it in this manner because this is the unit vector and this is the magnitude. Sometimes in questions only this magnitude is required. So depending on what the question is demanding, we can easily get it. This is a unit vector. If it wants in the vector form, then both are already given. But if it wants the magnitude only, then you should write 11 by 5 only. Let's take few more examples. In this, these are the three given vectors. We have to find component of A parallel to B. Okay, component of A parallel to B is nothing but A cos theta B cap again. So how we get A cos theta? Using dot product as the vector are in vector form. So this method is by far better. It is B cap. So by taking dot product of A and B, we get 3 into 2 6 plus 12, 8 plus 5 into minus 1, which is minus 5, and the magnitude of B is nothing but 3 square 4 square plus 5 square, root of that comes out to be root of 50. So this is an unit vector which is 3i plus 4j plus 5k by root 50. So we get component of A parallel to B, and this can be written as 9 by root 50. 9 by root 50 and B cap. This is B cap. So take one more example. For example, if we have to find component of B parallel to A. What if we have to find component of B parallel to A? We'll use B cos theta and the direction is along A, so obviously A cap. So what is B cos theta? Which is A dot B by magnitude of A now, and this will be A cap. Taking their dot product, again the dot product will come out to be same, but now the magnitude of A is 3. 2 square plus 2 square plus 1 square will give you 9, and root of that is 3, and the unit vector A, which is 2i plus 2j minus k by 3. So this is component of B parallel to A. So these two have no relations, just this is component of B parallel to A, another is component of A parallel to B. So what if now we take component of A parallel to C? Let's say it will be again A cos theta C cap, because it is now parallel to C. So take the dot product A dot C by magnitude of C into C cap. When we take the dot product of A and C, we are saying minus 2 plus 4 and again minus 2. This is 0. So no matter what the magnitude of C is or its unit vector, it will come out to be a null vector. Null vector is a vector of 0 magnitude, and that's why it can have any direction, it doesn't matter. So whenever two vectors are perpendicular, as their dot product is 0, these vectors are perpendicular, their component along each other will be 0. If we find out component of C parallel to A, it will also come to be a null vector or a 0 value vector.